Okay, in this video we're going to look at intersecting quadratics with lines and quadratics with quadratics. So the first one is quadratics with lines. There are some different possibilities here, and I've drawn some pictures for you to look at. So in this next picture, it's going to be a quadratic with a line where the line cuts the quadratic in two places. Okay, so you have an intersection point here and an intersection point there. So if you tried to solve this system, you would have two solutions. Okay. Now, another option is where the line doesn't cut twice, but it does touch it in just one spot. Okay, so in that case, you would have one solution. And then if you drop that line down a bit lower, you would have no solutions, no intersection points. Okay, so what does this look like mathematically? Let's take a look at an example here. So we've got an example of f of x equal to 2x squared plus 3x minus 5. Another one where it's g of x equals 3x minus 4. So to find the intersection point, what we're looking at is points where the x's and y's are in common. Okay, so for example, if we go up here, the x coordinate at this point is the same for both the line and the parabola. And so is the y coordinate. And same at this point. But at any other point, like this one here, the x coordinate here is the same for these 2 points, but the y coordinate is not. So that would not be an intersection point. So we're going to make the assumption that when we're looking for an intersection point, that the y's are equal. And we're going to show that we can find an x value. And if you can't find an x value, then there's a problem, and there is no intersection point. The assumption was wrong. Okay, so in these two here, we're going to look at setting the y coordinates equal to each other first. So set f of x equal to g of x, and you've got this. And now when you substitute in the functions, you've just got a quadratic equation. Just needs to be reorganized a little bit. Okay, so when you reorganize this, you've got, you bring the x's and everything to one side, so you have it set equal to 0. Okay, and now you've got a quadratic equation to solve. Now this one's nice to solve. You've got a couple options here. You can factor it, and you've got this, so it's a difference of squares. And then the solutions are x equals plus or minus 1 over root 2. Or you can bring the 1 to the other side, like over here, and then divide by 2, and then x equals plus or minus the square root of 1 over 2, and you can distribute that root in using this rule here. So that's root 1 on top and root 2 on the bottom, and root 1 is just 1. So this is one way of solving this. Now if there was a middle term in this, you'd have to use the quadratic formula or factor as well. Okay, so it just so happened we had 3x on both sides of this, so the 3x is canceled out. If that was a 4x, you'd have a very different equation. Okay. Now once you have the x coordinate, you don't have the point of intersection, you just have the x coordinates of the points of intersection. Okay. In this case, you're going to sub these x coordinates into g of x, which is probably the easiest one to sub into, or you could sub it into f of x. Remember, the y coordinates are the same. That's what we set. That's how we set this up. Okay, so you can sub it into either. I think it's easiest to sub it into g of x. So when we sub it into g of x, this is what we get for the y coordinates. Now, it's kind of hard to plot those, so what we might want to do is evaluate them to a certain number of decimal places. And so 0.1, I'm going to call it, and 0.2 are as shown here. And then when you evaluate them to, say, 3 decimal places, this is what you get. So you can now plot these two functions and identify approximately where the intersection points are. Okay, so what if we had something like this? This quadratic and this line. Now this quadratic you can graph. Okay, you know the vertex is at -3 and -5, and it opens down. And this one has a slope of -2, and it has a y-intercept of 11. So when you graph these, you're going to get this. and you can see that there's going to be no intersection point. And then we're going to prove it mathematically here. So we set f of x equal to g of x, just like we've done before. Okay? And then when we do that, now this one is in vertex form, so we have to expand this out in order to collect like terms. Okay, so expand that out. And keep going, and then bring everything over to the left side. And then you can divide both sides by -2. You can't do this if this is a function, but because it's an equation and you have 0 on the other side, 0 divided by -2 is just 0. So now we've got this quadratic equation to solve. It doesn't factor, so we're going to have to use the quadratic formula. Okay, and when you do, you get this. So this is the quadratic formula. Okay, and when we sub these values in, we get a negative under the square root sign. You don't have to evaluate it if you know that it's a negative. 5 squared and 4 times 17. You're comparing those two. Because it's a minus between them, 4 times 17 is bigger than 5 squared. You know it's going to be negative, and there's no solution. Okay. Now what about a quadratic with a quadratic? What are the possibilities with that? Well, here's some possibilities for two solutions. You could have them opening in opposite directions, like this one, or opening in the same directions, and one's wider than the other, different vertices. Okay. So that's for two solutions. For one solution, here's some possibilities. So they just touch like that, opening opposite directions. This one, one's inside the other and touches the other one. Or this one, it cuts through at one spot. Okay, so those are some possibilities for one solution. And then for no solutions, well, this is some diagrams for no solutions. Okay, so let's try an example for this. So two quadratics. How about these ones here? So intersecting those, same idea. Going to set the x or the y coordinates equal to each other. So f of x equals g of x. And then we're going to sub in the functions. Okay, we're going to collect everything to one side. So bringing everything to the left side. And when you do this, you've now got a quadratic equation, and it does not factor. You can check that out, but it doesn't factor. So we're going to need the quadratic formula. Okay, subbing in all the right numbers into the quadratic formula, you're going to get this. Now, it's pretty ugly looking at this point, so now you probably want to approximate it and use some approximate values. So I'm going to use x equal to approximately, that dot means approximately 2.23 and negative 1.43. So you might want to pause the video and make sure you get the same numbers. Okay. And as you know now, we've got the x coordinates of the intersection points. We don't have the y's, so we have to take these numbers and sub them into one of these two functions. Okay, so neither of them looks easy to sub into, so I'm just going to pick one randomly. I'm going to pick the f of x. So for the y coordinates, I'm going to sub in 2.23 into f of x, and I get 10.26, and negative 1.43 in, and I get 15.38. And now you can state the points of intersection. So therefore the solutions are this, the points of intersection are this as well. And that's it for intersections of quadratics with lines and quadratics.